Hey everyone, thanks for watching as always. Welcome to our latest episode of GoingNative. I'm Gabriel, Program Manager on the C++ team.
And I'm Steve Carroll, I'm the Dev Manager for the Visual C++ team.
So if you guys didn't already know, about a week back we finally released Visual Studio 2015 RTM. And so you guys need to definitely go and download that and check out the new stuff which we will be talking about today.
So today we're going to be talking about the standard template library in Visual Studio 2015, but all the code we're going to show is perfectly standard ISO CPP 11, 14, or 17. So the tricks you can learn today, regardless of what platform you're developing for and what compiler you're using, you should be able to use. A lot of our episodes are sort of future-looking, technology-looking. This one is going to be super code-focused. So we're going to do mostly code demonstrations and walk you through those new features. Welcome to another Going Native. Today we have Stephan T. Lavavej. Did I get it right?
Good work.
Yay! So there are, I think, 3 levels of fame in the world. There is, Kim Kardashian, super famous. There's like internet famous, like a YouTube star. And then there's like C++ internet famous. And you've cracked that 3rd tier. There's a 4th tier for us regular schlubs. Can you tell us a little bit about who you are, Stephan?
Let's see. I joined Microsoft in 2004. I joined the VC team in 2007. Since then, I've been maintaining the C++ standard library implementation, making cat noises and examples, that sort of thing.
Right. Okay, so you'll be making cat noises. What noises should I make during this video?
Hopefully not hiss.
Okay.
Yeah.
Maybe snarf?
Yeah,
all right.
snarf,
Snarf works. All right, great. So today we're going to talk about new things in the standard template library in Visual Studio 2015, but not all of this isn't a Visual Studio specific sort of thing. How are we doing on standards?
Oh, our conformance is close, but not quite to complete in the STL. We've got a whole blog post here, which I'm bringing up on the screen. If you look for the Visual C++ team blog, I maintain feature tables for all library and core language features. And over in the library, we are just 1 feature away from being C++ 14 complete due to a compiler limitation, and just 2 away from C++ 17. And that's actually because they voted the features in May, and we shipped like this month. So there's literally no way to jam those in. But all these other green rows are stuff we implemented newly in 2015. And we had a few that were supported in 2013. So a whole bunch of stuff, and also in the compiler, a whole bunch of features added.
So, Visual Studio 2015, at least from the library's perspective, is full of modernity. Is that?
Yes.
Okay, great. Let's get started. So what are you going to show us first?
So here you can see I've installed 2015 Community RTM on my Corp laptop. And I've written some short examples here. One of the cool features that was added to the core language back in C++ 11 was called user-defined literals. And the library was updated in C++ 14 to add some user-defined literals for standard library types.
Library-defined literals.
Yeah, exactly. Whenever we say user, people get confused. But as far as the compiler is concerned, the library is a user. We've got chrono literals for like seconds and milliseconds. We've got string literals for stood string. And we've got complex literals for imaginary numbers if you weren't horribly scarred by complex analysis in college like I was. So here I've got an example that shows both the UDLs and basic timing facilities from Chrono. Now, we had these back in 2013, but in 2015, we've got a major correctness and quality fixes. So high-resolution clock is actually high resolution, as its name would promise.
Is that like regardless of what platform it's on?
Yeah, this works all the way down to Windows XP and up to Windows 10. We use query performance counter for high-resolution clock. The system clock was also updated in 2015, but there the story is a little different. If you're running on Windows 7 or below, we use get system time as file time, which is like a 15 millisecond granularity, and that's the best we can do. But if you're running on Windows 8 or above, the STL will automatically switch to using a new API added called get system time precise as file time. And that has extremely high precision, almost like query performance counter, which is what powers high resolution clock.
So microseconds or
on the order of microseconds. It's like a handful of microseconds. So if you're like literally hammering it, you won't get like nanosecond resolution, but it's very precise.
So if you're doing small scale timing, you want to use high resolution clock instead of...
Yeah, the only time you would use a system clock is when you need to be able to display it as UTC, as an actual time that you display to a user. But if you're just calculating the differences between 2 times, either high resolution clock or steady clock is generally what you want.
Okay.
Here I've got just a simple profiling Sometimes you don't want to go spin up an IDE and get profiling that indicates what functions are hot and which ones are cold. Sometimes you just want to know how long does this chunk of code take. So here I want to see, okay, how long does a couple of couts and a couple sleeps that I've put in there just to make it take some time take. So all I need to do is call high resolution clock now, after including the chrono header, record a start and a finish, then I can subtract them. And if I want it in a particular unit, I can use this duration cast and say, hey, in milliseconds, give me the count of how many there are. And I can just print that out. I could also ask for nanoseconds or whole seconds or whatever I wanted.
That is so much better than having to remember what to do. Oh, yes.
Yeah, you could use query performance counter and use large integer, or some people would use the CRT's clock function, but that is low resolution. And
even just losing the divide by 1 million piece of this is great.
To scale. Here you can just work with actual SI units. And then if you need to give chrono const to something like sleep for or wait for, previously you would have to say, okay, I want to construct object of type seconds from 1 or 2 or whatever. But now with user-defined literals, you can simply say 1s. And previously this would have been totally bogus syntax. But now the library says, oh, if you see an integer followed by s, this must mean a std chrono type. And s means seconds. We've also got ms for milliseconds. So I can build this and run. And here I get meow per with 1 second delays, and the whole thing took 2,029 milliseconds. So that's just basic use of the chrono facilities and UDLs.
It's 1,000,000 times more readable.
Yeah. I can also debug into what the UDL does, because it's not doing anything magic. It's exactly equivalent to constructing a seconds from 1. So if I run and okay, it's printing meow, gets here, and if I step in using F11, this will take me into what 1s does, and here it's taken me into the chrono header of the STL, and it calls this funny thing operator double quote s, and this is a user-defined literal operator, and the compiler just says, oh, if I see 1s, I'm going to call this funky operator with the value equal to 1, and then I can construct an object of type chronoseconds and return it. It's inline, it's const expr, it is just going to optimize away. So you don't pay any extra cost for using a user-defined literal.
Hey, I'm going to take this as an opportunity. Can you go back there really quick? As you said, a lot of times what you want to do in the debugger while you're doing things is actually step through things just to time how long particular statements take, and you can actually see the...
Yeah, you got that here.
That's Visual Studio 2015 debugger
cool.
feature right there. But this technique is still super useful when you want to time the code not under the debugger, which is usually what you want to do.
Especially in optimized mode.
Yeah, exactly. That's a freebie.
So that is the first example I had here. The second example I had here was just a small convenience utility for working with tuples. So sometimes you just need a struct with a few members, but you don't want to go define a struct with differently named data members because you're only going to use it for like a function or two. And tuple is really convenient for being lazy. You can just say, oh, I want to bundle up like an int, a string, a double, and then pick apart its components, store stuff in there, and then be done with it. And you can work with it as a unit. You can have a vector of tuples, stuff like that. And in CS+11, what you had to do was you had to index tuple members by 0, 1, 2, because it was zero-based. Unlike pair, where you have first and second data members with names, because a tuple is flexible length, we can't give the variadic data members names. So you had to use indices. But if you're working with like large tuples, you're working with it over the span of a function, you're like, okay, which one was number 1, which one was number 2? It's easy to get confused. So in CS+14, they added a feature, getting by type. And this has just been overloaded. So I can access a tuple with the old way, but I can also say, oh, I want to get the int data member of this tuple, or get the string, or get the double. And as long as the type is unique in the tuple, you're OK. If I had like a tuple of in and int, then get int would be ambiguous. That would be rejected.
What would it actually do?
It would be a compiler error. And in fact, I can.
Oh, wow.
Here I can build this and show you what it looks like. So here, the accessors are exactly the same regardless of whether I'm using indices or types. But imagine that one of these types was duplicated. So imagine that I want to go mess up my code with a tuple of multiple data members. So imagine I had like a tuple of int, and string. And this one will be duplicates. And imagine I got like 11, 22, and kitty.
Snarf.
Snarf. So I could say get string from this tuple containing duplicates, and this will work fine. In fact, I can save and run. And here I was able to access a string from this tuple because the string type is unique. So that's great. But if I attempt to access an int, this is obviously not going to work because the compiler cannot possibly know which one I want. Doop and out. And if I save and attempt to compile this, I will get an error. And no, I do not want to run the error build. And this error window, which I don't think I can zoom in, gives me a wonderful compiler error, but it's not as horrible as it looks like. In fact, the standard library, we've actually gone to the lengths of telling you exactly what's wrong. We say error C2338, duplicate type T in get T of tuple. So we just need to go look at the line it's complaining about, which is meow CPP line 16. And so you go to line 16, you're like, oh, there's duplicate type. Oh, wow, there it is. So in the standard library, we're trying to help you understand these large template errors. But as long as the type is unique, then it's fine. And one of the cool things about this get by type functionality is it doesn't just work for tuples, it also works for pairs. So you can access, if you want a uniform interface, pairs with the get by index or the get by type, and again, the type needs to be unique.
Which I guess would be good for generic usage.
Yeah, you take an arbitrary tuple-alike thing, and it could be a tuple or a pair. And then you can just access it uniformly. So
nice.
Maybe you're working with like a map, because remember map key values are pairs. So instead of saying p.first for the key, you could say get the key type from the map's element, and that could be quite convenient.
All right, next up.
So the next example that I have, this is a whole header that was added to CS+14. And they actually renamed the type just before CS+14 was released. That was actually a Microsoft proposal to rename the type. The header is called shared mutex. And the type is now called, in CS+14, shared-timed mutex. And the idea is, imagine that you have some sort of centralized data structure that a bunch of threads could be simultaneously reading, and that's safe to be reading a data structure. And occasionally, one thread needs to go in there and update, write to the data structure. And you've got all these readers and these writers hammering the centralized data structure. In CS+11, this was kind of problematic because all of the mutex types didn't permit multiple different threads to simultaneously hold the mutex. And in CS+14, they added what is often known as a reader-writer lock. And in C++, it's called a shared mutex. The type has timed in it because it also has timed waiting functions you can wait for, wait until, but you can also ignore that stuff and just use the non-timed waiters. So I have a fairly elaborate example here where my centralized data structure, it's actually, I'm not even messing with the data structure. I'm just having different threads acquire and release this mutex either as a writer pretending to go write or as a reader. And I want only one writer to ever be holding the thing. But I'm going to allow multiple readers. So I've got this set up so I can have 3 threads attempting to write, 3 threads attempting to read, and they will sleep for some random number of milliseconds just to pretend that they're doing some amount of work. And the difference between these two is that if I want to acquire this shared time mutex object here as a writer, I need to construct a unique lock. And unique says I need to be the unique person holding it, so I'm going to write. But if I want to be a reader, then I construct a shared lock, saying I'm willing to share access to this data structure because I'm only reading it.
What is the MT19937?
Oh, this is part of our random number library, which we shipped back in 2008 SP1 and have continuously improved since then. What you do for this is you include the random header, and this is a Mersenne twister. You can read about it on Wikipedia, and it's a very high quality, very fast pseudo-random number generator. I'm actually seeding it here from a random device, which also comes from the random header. And this is a source of non-deterministic random numbers. We actually get these from Windows using a special API. So the output of this program will be different every time I run it. But I'm not using a random device directly because it has the potential to be slow. So I use it only to seed this Mersenne twister, and then I can use this to generate random numbers very quickly. And that's what I would do in production code, even though this is just sort of a toy example. So I can take this code, it all looks good, I've saved it, build, there we go. Oh, and pro tip, I actually had to learn this. If you hit F5 with a console program, it'll run all the way to the end, and then when it gets done, the window just closes. And you'll see lots of newbies learning C++ saying, hey, my window closes, and they put like a system pause or a cin, whatever at the end. You can put a breakpoint at the end to stop that, or you can just say start without debugging, and that won't attach the debugger, but it will allow the window to stick around even when it's done. So here this will run for a bit and then terminate, and the idea behind my output is that here I can see multiple readers like threads 3, 4, and 5 all simultaneously doing work, but whenever a writer gets in there, writer 0 starts and writer 0 finishes before another writer comes in. And I even put little carrots, little arrows here just to show that when a writer has acquired this shared time mutex, it's exclusive. No other writers are interleaved. And yeah, it's all done here.
Great. So reader-writer locks are like something you definitely don't want to have to write yourself.
Yeah, getting this right was pretty tricky.
Yeah, we've been known to use those as interview questions. Yeah. So great.
So yeah, that's shared timed mutex. Now the next example I have is something that was added in CS+17. So in the STL, we've been racing ahead trying to implement standards literally as they're voted into the working paper. And this resolves actually a long-standing sort of deficiency with stdmap that has been present since CS+98. So imagine that you've got a map. Here I've just got a map from ints to strings, and you want to insert or update a value, and then you want to be told what happened. Did you do a fresh insertion, or did you update an existing value? So in CS+98, you had a couple options. You could use the bracket operator, which somewhat counterintuitively will create an empty value if you didn't have one already. So here, starting with an empty map, I could say, okay, m of 1 equals cat, and that will insert a new key of 1 and a value of cat. And then I can go print that out. And if I want to update that in place, I can say, okay, m of 1 needs to be equal to meow now. And this will assign the value meow to m. However, although I can do this and I can update the value, I don't get informed whether I got a fresh insertion or an assignment. And sometimes I'm interested in that information. And I don't want to have to pay like an extra find, an extra lookup to find that out. There's another interface available all the way back to CS+98, insertion. And this is sort of the opposite. If I call insert with a key value pair, then I can be told, because it returns a pair of iterator and bool, the bool component tells me, hey, did I insert this thing? So if, and actually I guess I can put a breakpoint here and show you what happens if I run this thing. And let me bring up that window. Okay, so if I use operator bracket bracket, I get a fresh insertion of 1 cat, and I can update that in place to 1 meow. If I use insert make pair, then I get a fresh insertion, and insert tells me, hey, it's true that I inserted something. And then if I try to insert the same key with a different value, it returns false, saying, no, this thing was already present, but I don't get the value updated. What if I want both of these things? What if I want to be able to insert or update the value and yet be informed which happened? That's where the CS+17 feature called insert or assign comes in. So if I can say insert or assign the key 3 and the value owl, and then later I can change my mind and say, okay, insert or assign the key 3 with the value hoot, and then if I step forward, we'll see what happens. If I go 10, 10, 10, 10, then here I inserted a new key 3 value owl, and I got true, saying the insertion happened. And then I update that key 3 to have the value hoot, and it returns false, saying the insertion did not happen. I got the assignment. And this is all done with a single log time lookup into the map. So it's efficient, it's less coding than doing like a separate find and then an insertion, just a small convenience thing.
It's awesome. So it's like a new way to interact with an old favorite.
Yeah, and this also applies to unordered map, which is the hash container. And then there's another API try in place, which is much more advanced. But it's all there, and the paper that proposed this for the standard is available, which is a nice sort of high-level introduction to what the feature does. Another example I have, this one is actually one of my favorite features because I proposed it for the Library Fundamentals v2 technical specification. And a certain development manager graciously allowed me to check it in between RC and RTM when we're really not supposed to be adding extra features to the product.
Don't tell the internet!
But yeah, we checked it in. We managed not to break anything. So this shipped in 2015 RTM, and it's called Uniform Container Erasure. And this solves a long-standing, really obnoxious thing in the standard library. And that's if you have a data structure like a vector or a list or a set or whatever, and you want to eliminate unwanted elements, like all of the integers that are odd, or all of the enemies who have negative hit points, or all of the databases that are corrupt, or whatever your data structures are. I just use integers because integers work. Doing so is actually surprisingly non-intuitive. You have to learn this thing called the erase remove idiom for vector, but it turns out you do not want to do that for std_list. And in fact, it's totally inapplicable to std_set, where you need a third type of handwritten loop. And people screw this up all the time. And it makes for a great interview question, but for production code, it's not something you want to do. So what these experimental features do is you need to include the header's experimental slash and then whatever data structure you're using. So here I'm including the experimental versions of vector, list, and set. These drag in the ordinary data structures. We're not actually changing std vector and std list here, but it also adds std experimental erase if and std experimental erase functions that I can then use. I've got a using directive here. So the usage is actually very simple. Here I've got some containers. I can print them out before. Here I've got a lambda, but I could also just pass a function pointer or a whole function object written from scratch. And this just reports, hey, is this integer even? You know, is n mod 2 equal to 0? And then usage is as simple as saying, okay, erase all the elements from V if is even reports true. So I want to erase all the even numbers and be left with only the odd numbers. And if I run this, what do I get? It compiles and runs, and the before of these containers is 1, 2, 3, 4, 5, 6, and so forth. And then after erasing the even numbers, I just get 1, 3, 5. So I didn't need to write a loop at all. In fact, the only loop in this whole program that I, as the user, have written is the one to print stuff, just because I don't like that ostream iterator thing you might have seen. I can debug in here and show you the 3 different erasure techniques that these are using. So let me run with debugging. And if I step in, here this takes me to the experimental vector header. In the tooltip it says include experimental vector. And what this header does is it just drags in the standard vector. This part is guaranteed by the technical specification. And then it adds a couple overloads. And this erase if that I'm calling does the famous erase remove idiom that uses the std remove if algorithm and then uses erase to actually get rid of the stuff. And if you just call erase if, it'll do that for you. You can forget about the erase remove idiom. So that's nice. But what about std list? What does that do? I mentioned that we actually need to do something different for std list. For std list, it actually has a member function called remove if that counterintuitively actually erases elements. It's quite badly misnamed. And here it's been put inside a uniform interface, just called erase if. This is actually more desirable than the erase remove idiom for various reasons. It turns out it doesn't assign elements, and just getting rid of nodes in place is more convenient. But then I mentioned that it's even harder for std set. So for set and map and other node-based non-list data structures, what does that do? Here we're calling a helper function. You can tell it's internal because of this underscore capital. That means it's reserved and users can't mention the name. And what this does is it does a raw loop over iterators that checks, okay, if it satisfies the predicate, we don't like it, so erase it, and then update the iterator so we don't erase the iterator we were just standing on. And if it's not detected by the predicate, then just increment the iterator to skip over it. And this will individually erase according to whatever criteria you like. Of course, it's a linear time algorithm, as the name suggests, so it does not do any sort of logarithmic lookup in a set. Because if you give me a predicate, I need to examine every element to figure out whether to keep it or not. So that is something that has been voted in to the Library Fundamentals v2 technical specification, and hopefully will become a part of the CS+ standard, whether 17 or some future standard. But we're shipping it now so that we can gain implementation and user experience. The library working group iterated on it, so one suggestion that I incorporated was I originally had erase for values overloads for set and map. And many people thought that that was confusing. And in the end, I agreed. It's confusing to have a non-member function called erase for set that does a linear scan. But if you call a member function erase, that does a logarithmic key lookup. And that's just too confusing. So for the
simplified it.
Yeah, for the associative containers, we only have the erase if that takes a predicate. But for vector and list, where there's no chance for confusion, we have both erase if and erase. If you want to erase like all the values that are 0, things like that.
Got it.
The final example that I have here, which I enjoy tremendously, is breaking users' code.
No!
And, yay! I love to break code. And especially love to break deprecated code. So the example
okay, well
here,
that's all right then.
and this is actually another one of my proposals, is in CS+ 17, the committee has decided to remove the very dangerous class Otto Porter. And yeah, cat noises. And also a couple of algorithms, random shuffle, and some old functional things like putterfun, memfun, that turned out to be just clunky and yucky. So these things, like Otto Porter, was in CS+98, and it's really the world's dumbest smart pointer. And it's not a good kind of dumb. It's like, oh, it's super dumb, seriously. And in CS+11, we gained unique putter, which is much safer, much easier to use. It's what Otto Porter should have been, but it relied on features that were new to CS+11. And so in CS+11, they deprecated Otto Porter. It remained deprecated in 2014, and it's finally been removed in what will become the CS+17 standard. So in VC 2015, we're still shipping Otto Porter. I'm not quite that aggressive, but we have an opt-in macro. So if you want to be on the leading edge of conformance, if you define this macro, has Otto Porter, etc., to 0 project-wide, we in the standard library will shut off all of our definitions of Otto Porter, and you can verify that your code is not using any of this deprecated and removed functionality, and you're only using new stuff. So hopefully people like Boost and other libraries will start to migrate their code away from Otto Porter, and in the next major version, we'll be able to turn this to be removed by default, and then maybe completely remove it unconditionally at some point.
So I think we want to turn that into explicit guidance, though, which is if you suspect that you at some time had foolishly chosen to adopt the old Otto Porter.
It was standard.
Yeah. Well, you have a good excuse, but the time has come to come clean. Please take your code, set this thing, set this /d so that you can try to identify these things and start to pull it out now.
Yeah.
There's a better option. This shouldn't be that painful.
Yeah, in fact, migration is so simple that there are some automated tools that will convert Otto Porter directly to unique putter. And direct analogs do exist for some of the functional stuff, for some of the shuffles. But Otto Porter in particular is almost completely mechanical. So here I can actually show you what that looks like. Now, I mentioned you really should do this project-wide with a /d sent to the compiler either through a make file or through the Visual Studio build system. Here, because I'm lazy, I'm just going to do it with a pound define. But this is not preferred just because if you're doing pound define, you can't ensure that you're getting every single source file. You really want this to affect all standard library headers. But for a single source file, meowcp that I have here, just to define is fine. This is _capital, but I'm documenting it as the Visual Studio way to shut off Otto Porter. So if I do this before including any standard library headers, you'll now see that IntelliSense is already detecting, whoa, where'd Otto Porter's definition go? And I'm getting squiggles around it. And if I attempt to
pointing out your secret shame.
I know. So if I attempt to build this, I will get a delicious compiler error. Here we go. And it says error C2065, Otto Porter undeclared identifier. And that's because this macro has completely ripped out Otto Porter's definition from the memory header. I think I can go there and we can look for hands, Otto Porter, etc. And here we go. This is what it looks like in the standard library headers. We've simply wrapped every mention of Otto Porter. Here this is one of sharedputter's member functions that takes an Otto Porter, and anything that mentioned the Otto Porter or any of the other removed stuff had to be guarded by this macro. So here's another sharedputter thing, and then the actual definition is near the bottom. Oh no, we put it in another header. But basically this ensures that nothing tries to use inside the standard library a class that has been removed. And we've done this for random shuffle. I thought about for like a microsecond having separate macros to control Otto Porter separately from random shuffle, separately from functional, but having like a zillion macros would be way too confusing. So that's why the macro is named has, Otto Porter, etc., because it controls all the things that were moved in 17. So the first step will be to eradicate this usage from Visual Studio itself, and then I can turn this on, and then maybe we can spread it over to customers, and then do it unconditionally. Yes, break all the code.
Right, but as soon as you get 2015, you're set up so that you can remove this from your own code.
The macro will be available, but the default is to provide it. We are shipping some breaking changes, but that are much less invasive than this huge class that's been around since CS+98. That's what you got to do if you want to move code forward. I mean, breaking legacy code, it's not something that is fun, but it's necessary if you don't want the standard to just grow and grow and become saddled down with all these classes that we've known how to do better for almost a decade now. So that's the story.
Great. So what's next for the STL for us?
Well, this feature table here shows that we got a little bit more work to do. One of the features that we'll have to implement is something that users have been asking for in result of and std function. we need to use expression sphenae to make the result of nested double colon type or the stood function constructor disappear when things aren't callable. There are ways to hack it around if you don't have expression sphenae, but I just want to use that compiler feature rather than adding more complexity to the library.
Right, and 2 team rooms over, the compiler team is furiously implementing that particular feature so that we can get out. Anything else?
Yeah, I'll be the first tester of that. And then we'll have to implement these things that they voted into CS+17. They messed with pair and tuples constructors, making basically the explicit on them sort of conditional, which is something the core language doesn't really support, but we can do it anyways in the library. So we'll have to add that. And then I had mentioned earlier that the shared mutex header has this type shared timed mutex. One of the things that was voted into CS+17 is a type shared mutex, which has no timing functionality that will live in the shared mutex header.
Is it more efficient? Or?
Yeah, it turns out this can be implemented more efficiently on Windows without the timing functionality. It directly maps to the SRW lock, the slim reader writer.
Sure.
And one of the reasons that Microsoft proposed the rename of shared mutex to shared time mutex is to make space for this shared untimed mutex type. It turned out after we got that voted in that not just Windows benefits from this, but I've been told that the Mac platform also can implement a shared untimed mutex more efficiently. So this is good not just for Windows, but for other platforms.
That's one of ours? Core?
Yeah, well, the rename was ours, and then the proposal to have the shared untimed mutex was our proposal. Goran Ishanov, who sits on the desk next to mine, got that proposed and shepherded through the library working group.
You mean the star of the last episode
Yeah,
of GoingNative?
he doesn't just work on Await, he works on other stuff.
Yeah, sweet. All right.
And then we'll be able to declare victory for at least the standard library, and then the compiler will have more features to implement. But over in the standard library, these features are what I'm concerned with. And we've got some library issues that need to be implemented too, but those are more on the level of bugs, not something that are super interesting to most users, except for the stood function constructor that many people run into.
Okay, great. Thank you, Stephan.
Cool. Thanks, Steve.
That was our episode for today. Thank you so much for watching. Let us know what you think in the comments below, and we'll see what we come out with next month. But speaking of next month, I am actually personally going to be taking a step back from the Channel 9 GoingNative production process. But on the plus side, I did find a replacement for me, and I think he's actually here. Let me go get him right now. And
Hello, I'm Gabriel Dusters, the real Gabriel.
All new and improved Gabriel.
Yeah.
No, just different, not necessarily improved.
I'm software engineer on Steve's team, and he's my boss, but
But we don't let that come between us on the internet, right? Yeah. All right, so call to action. Please, by all means, go download Visual Studio 2015. You can get the community edition and try it out. Send us feedback, and we'll jump on it. Thanks.